Hello friends, have a nice day. This is Professor Dr. G.S. Wajire from Department of Electronics, Sri Shivaji College of Arts, Commerce and Science, Akola. Today's topic for discussion is bidirectional and universal shift registers. Friends, to understand today's topic, you are supposed to know the basic knowledge of flip-flops and shift registers. In previous lectures, already we have discussed both these topics, but for your kind understanding, we will go through the basic concept of shift register and flip-flop. So, register is the group of flip-flops which is used to store the binary data or binary number. Normally, one flip-flop is required to store 1-bit data. The shift register, we can say a register which is used to move, to shift, to transfer or to rotate the data in various ways. Here the input can be given in serial or parallel way and output can also be taken in serial or parallel way. So accordingly there are 4 ways of data movement. So first is serial in, serial out. In short, we call it as SISO. Second is serial in, parallel out. It is SIPO. Third one is parallel in, serial out, which is PISO. And fourth is parallel in, parallel out. That means PIPO. If we talk about bidirectional shift register, so in this case the data can be shifted or rotated in 2 directions. That is, first is shift right. That means here the data is shifted from left to right. And second is shift left. That means the data is shifted from right to left direction. Next, come to universal shift register. If above 4 ways of data movement, that means these 4 ways, and 2 ways of data shifting, that means these 2 type of data shifting, and holding of data is possible, then such a shift register is called as universal shift register. That means this 4 type of data movement, this 2 type of data shifting and data holding capability. These 3 conditions are necessary, or we can say mandatory characteristics of universal shift register. Now come to this block diagram, which is 4-bit shift register. Now as per our definition, here all 4 combination of data movement is possible. If we observe on left side, then this serial data is loaded into this shift register. From this right side, the serial data can be taken output from this shift register. If we see on top side, then from this side we can see the parallel data can be input or can be loaded into this 4-bit shift register, and from this bottom side we can say the parallel data can be taken out from this 4-bit shift register. In order to use this 4-bit shift register as a bidirectional shift register, we need to add mode control circuit for shifting the data from left to right or from right to left directions. All these 4 flip-flops are clocked simultaneously by using this clock signal. Additional facilities of preset and clear are given with this 4-bit shift register with this circuit diagram. Now come to this slide, which is IC 7495. This IC is used for 4-bit universal shift register. This is 16-pin IC which is available in dual-in package. In short, it is called as DIP. This IC works on plus 5 volt. This plus 5 volt, it is given with respect to VCC, which is pin number 16, and between pin number 8, which is ground pin. Clock signal is given to pin number 11 These clear facilities are provided with this pin number 1. Pin number 2, it is used for shifting the data towards right side. That means data is shifted from left to right side. And of course pin number 7, it is used for shifting the data from right side towards left side. Here pin number 3, 4, 5 and pin number 6, these are used as parallel data input pins. And similarly these pin numbers 12, 13, 14 and 15, these are used to output data parallelly. These remaining 2 pins, pin number 9 and pin number 10, these are controlling pins, and the actual operation of this shift register is decided by the combination of these 2 pins, which are also called as mode control pins. Actually, combination of these pins decide the operation of this universal shift register. Just if this combination is having both 0, 0, then this shift register is used to hold the data. If this combination is 0, 1, then this shift register, it is used to shift the data towards right side. If the same combination is like 1, 0, then the data is shifted towards left side. And last, if the combination of this S1 and S0 is 1, 1, then this universal shift register, it is used for parallel mode of operation of data. Here one more thing is given, that there is a notch on left side of this IC, and normally this notch is used to identify the pin numbers. From left side of notch, these pin numbers get started and they start counting from 1 like this. The numbers, they are going increasing in this manner. Now let's go through applications of shift registers. There are various applications. We will take in brief one by one. First, we can say shift registers are used in time delay circuits. This SISO shift register is used to introduce the time delay in the signal as delta T equals to N into 1 over Fc. Here N is number of stages and Fc is the clock frequency. These shift registers, they are also used for serial to parallel conversions. Next, these are also used to convert parallel data into serial mode. That means they are used as parallel to serial converter. Next, we can say these are also used as up-down counters. These counters are used for counting up or down sequence of input clock pulses. Also, they are used as ring counters, in which the serial output is connected back to the serial input. The shift registers, they are also used as twisted or Johnson's or Mobius ring counters. In this case, an injected pulse will keep circulating in the square waveform pattern. And finally, these shift registers, they are also used as sequence generator. This sequence generator is a circuit which generates a prescribed sequence of the bits, which is called as a sequence generator circuit. So friends, let's stop here. Thank you very much.